Hi, and welcome back. So this is part 2 of section 9.7, graphs of the 4 other trig functions. Part 2 is going to be about the tangent and the cotangent graphs. Now, before we get too far, you might want to go grab your graphing calculator. You will want that for this lecture as well as the next video, part 3 of section 9.7. So maybe pause the video now, go grab your graphing calculator, and then come back. I also have an assistant today. This is my dog Midnight, and she has decided that she's gonna help out for today. Okay, so in this lecture, in this video, we're gonna talk about the tangent graph and the cotangent graph. So we'll start with the graph of the tangent function. Now, one thing you can do here is, you can immediately go into your graphing calculator, use the Trig mode button, and you can graph this tangent function and you get a picture of it. But my goal in this video that we're talking about here is to kind of get a sense of how can we replicate this graph and how can we at least understand parts of why this graph looks the way that it does. Okay, so we need a little bit of information. One piece of information that we need is the identity, the quotient identity that we talked about in the last video. So we talked about how tangent of theta is equal to sine of theta over cosine of theta. Okay? And this piece of information is going to help us to figure out where this particular graph has zeros, in other words, where this graph crosses the x-axis, and maybe some places where this graph is going to be undefined. Okay? So when I look at tangent of theta in terms of sine of theta divided by cosine of theta, the places where the numerator is equal to 0 are places on the graph where the graph crosses the x-axis. And places where the denominator is equal to 0 are places where our function is undefined. And so our graph will be undefined, and it turns out we'll have a vertical asymptote. Okay, so let's start to get a picture of this tangent function and see what we can graph based on what we have so far. All right, so this tells us that when our numerator is equal to 0, because anytime you have 0 divided by something that's not 0, the whole fraction is 0. When our numerator is 0, then our tangent function is going to cross the x-axis. So let me think about what the sine function looks like. Y equals sine of x. Well, the graph of y equals sine x, take a minute and think about what that looks like. Okay, this is our parent function, the sine function, and so this sine function, if I draw a couple of periods of the sine function and mark a couple of values on it, so we can mark pi over 2, pi, 3 pi over 2, and 2 pi. And I can also do the negative versions of those. Okay. Then what I can see is that our sine function is equal to 0. Sine of x is equal to 0 when the x value, or the angle, is equal to 0, and pi, and negative pi, and 2 pi, and negative 2 pi, so plus or minus 2 pi, etc. So 0, plus or minus pi, plus or minus 2 pi, plus or minus 3 pi. Those are all places where our graph of the tangent function is going to be 0. So maybe I should mark a few of those on our graph. So we can mark some important features on our tangent graph, and I'll start by labeling kind of all of these same x values that we had on the sine function. We have pi over 2, pi, 3 pi over 2, and 2 pi, and also the negative versions, negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. Okay, and x values where the sine of x is equal to 0 are 0, pi, negative pi, 2 pi, and negative 2 pi. Okay, so those are all places where a tangent function is going to cross the x-axis. All right, now we can look at the denominator. The denominator of our tangent function is cosine of theta. And so when I look at that one, when I look at the cosine function, and I'm going to draw a picture of what that looks like, 2 periods worth of it. So I'll make a few marks. So I'll start by drawing the picture. So here is our cosine function, 1 period of it off to the right, 1 period off to the left. And I'm going to mark all the important features again. Pi over 2, pi, 3 pi over 2, and 2 pi. And over here on the left, all of the negative versions, negative 2 pi, negative 3 pi over 2, negative pi, and negative pi over 2. So here's a picture of our cosine function. Okay. And because we're looking at the denominator, and we want to know what input values are going to make the denominator equal to 0, because you never want to divide by 0. So we want to figure out what values make the denominator equal to 0. Well, our denominator is the cosine function, and the cosine function is 0 at pi over 2, 3 pi over 2, negative pi over 2, and negative 3 pi over 2. So these are places where our tangent graph will be undefined, and we're going to end up having a vertical asymptote. So here we have a vertical asymptote at pi over 2, at 3 pi over 2, at negative pi over 2, and at negative 3 pi over 2. Okay, so now we have a couple of things going on. We've got vertical lines, places where our tangent graph will not cross those vertical asymptotes. And we have places where our tangent graph is going to cross the x-axis. Okay, one last piece of information that we can fill in has to do with the sign, SIGN, of the tangent function. So the sign of tangent of theta, so thinking about the 4 quadrants, quadrant 1, quadrant 2, quadrant 3, and quadrant 4, the sign of tangent, so tangent is positive in the first quadrant, and positive in the third quadrant, and negative in the other 2 quadrants. Okay. And you can think about that in a lot of different ways. Either all students take calculus, or in the first and third quadrants, x and y. In the first quadrant, x and y are both positive. In the third quadrant, x and y are both negative, so they cancel and make a positive value. Okay, so what does that mean for us? If I think about, make sure the camera moves back far enough so you can see my arm swinging. Okay, as we're swinging around on the angles, okay, from an angle of 0 up to pi over 2, the tangent function is positive. What does that mean on our graph? From 0 to pi over 2, our tangent function is positive, which means the graph of the tangent function will be above the x-axis. So our graph is going to show up in this region. Okay. Okay. From pi over 2, that's 90 degrees. From 90 degrees to 180, so from pi over 2 to pi, that's quadrant 2, pi over 2 over to pi, the tangent function is negative, which means the graph of tangent will be below the x-axis. So from pi over 2 up to pi, we expect our graph to be in this region. And then from pi to 3 pi over 2, so that's from 180 degrees to 270. So from 180 degrees down to 270 degrees, tangent is positive. So from pi, or 180 degrees, to 270 degrees, or 3 pi over 2, the tangent function is positive, meaning the graph will be in this region. And finally, from 3 pi over 2 up to 2 pi, the tangent function is negative, so our graph should be in this region below the x-axis. Okay. And I can do the same kind of argument over here on this left side, so you can kind of see the pattern that's going on, I hope. So here are the shaded regions, the places where our graph of the tangent function is going to be. Okay, so here's what we have so far. And you might start to take a guess at what this graph looks like, and if you're daring, you might try and draw it yourself, but we're going to take a look at the graphing calculator. Okay, so here we have our graphing calculator, and I'm going to go into the y equals button and type in tangent of x. Now, before I actually graph this thing, I want to go to my mode and make sure that my calculator is in radian mode. Okay, so it is. So we have the tangent x function. I'm going to hit zoom and go down to zoom trig. When I do that and I hit enter, check out what's happening. Now, something that you might notice is that my calculator has these vertical lines. Yours may have those, or it might not, depending on which version of this calculator you have. So take a minute and draw that on your calculator, or type it into your calculator, and I'm going to draw this up on the board. Okay, so here are the pieces that we have. I'm going to start with the middle piece between negative pi over 2 and positive pi over 2. We have this branch that starts really low. It pops up, it hits the origin, and then continues upward. Okay. And this is one piece of the tangent function. Notice how we were right about shading these regions. That's where the graph actually shows up. Okay, I'm going to do the same thing with the next section. And then on the last one, we'll start low here and pop up. Now we're going to stop at an x value of 2 pi. You could keep going, but we'll just stop there. And I can do the same thing on the left side. So here we have another branch, and then finally I only have half of a branch here. It starts at negative 2 pi on the x-axis and pops right on up. And so we now have a graph of our tangent function. Okay? And you want to get really good at drawing this graph of the tangent function. And you also want to maybe think about some of the properties of this function. So properties of the function f of x equals tangent of x are as follows. So here are the important properties. We want to know things such as domain. Well, when I look at this tangent function, we get an input for every single x value except those that occur on the vertical asymptotes. Okay? So the domain is all real numbers except x equals, okay, so those vertical asymptotes are occurring at plus or minus pi over 2, plus or minus 3 pi over 2. And if I wanted to keep going, I would have plus or minus 5 pi over 2, plus or minus 7 pi over 2, etc. The the range for our tangent function, so remember the range has to do with the y values that you're allowed to get. And if I think of a little guy here that's rock climbing up and down the y-axis, when he's rock climbing and climbing up the y-axis, he'll see part of the graph to the left and to the right. And no matter how far down he goes on the y-axis, he also still sees part of the graph. So the range for this function is all real numbers from negative infinity to positive infinity. Okay, so we've got our domain, we've got our range. Period is the next thing. This period's a little bit different than the sine and cosine functions because take a look at this. You have one full branch of this function, and that full branch repeats itself over and over again. And notice how far it is between the beginning to the end of one branch, from negative pi over 2 up to positive pi over 2. Positive pi over 2 up to positive 3 pi over 2. The difference between those two, the beginning and the end of the branch, is the distance of pi. So this is different than the sine and cosine functions. In this one, the period is pi for tangent. All right, the final important property of the tangent function is that we have vertical asymptotes. And those vertical asymptotes, well, we have them drawn over here. And the vertical asymptotes are x equals plus or minus pi over 2, x equals plus or minus 3 pi over 2, etc. Okay, so this is our tangent function. You want to be really comfortable being able to draw this function. I kind of think of this function as kind of the Saturday Night Fever function. It kind of goes like this. And so when you're thinking about the tangent function, think about Saturday Night Fever and do your dance. All right, now we're ready for cotangent. So the cotangent function, if I think about that function, again, we want to eventually draw the graph. And some things I want to think about are how can I sort of envision what this graph looks like before I throw it into my calculator. And one thing I know is that cotangent of theta is cosine of theta divided by sine of theta. And that comes from our quotient identity from that first part of our lecture today. All right, so cotangent of theta is cosine of theta over sine theta. And I know that our cotangent function will cross the x-axis. We'll cross the x-axis when the numerator, which in this case is cosine of theta, is equal to 0. And our cotangent graph will have a vertical asymptote and will be undefined when the denominator, or sine of theta, is equal to 0. Okay, so thinking about the numerator and thinking about the cosine function, I'm going to draw a really quick sketch of my cosine function. Here it is. Boom. You're probably really good at drawing the cosine function by now. If you're not, you want to get really good at it. And I can mark some values on here. I have pi over 2, pi, 3 pi over 2, and 2 pi. And I also have the negative versions of all of those. And so I know that I'm going to have a place where our cotangent function will cross the x-axis when the numerator is 0, so when cosine is 0. So zeros of our cotangent function will occur. So zeros of cotangent occur when our input is plus or minus pi over 2, plus or minus 3 pi over 2, etc. Which means I can start to draw some things. Okay, so I'll mark the important values on the x-axis. And this will be our graph of f of x equals cotangent of x. Cotangent will cross the x-axis when cosine is 0. So that's when our input is positive and negative pi over 2 and plus or minus 3 pi over 2. Okay? On the other hand, we're going to have vertical asymptotes when the sine function is equal to 0. So when I draw this picture, and I might have this picture in my head, but I like to draw it out. So here is my sine function, and I mark all of the important points on it. So I have 0, pi over 2, pi, 3 pi over 2, and 2 pi. And then I have all the negative versions. And our cotangent function is undefined when the denominator, which is our sine function, is 0. So where is our sine function 0? Our sine function is 0 when the input is 0, when the input is pi, when the input is negative pi, when the input is 2 pi, and negative 2 pi. So these are places where we will have vertical asymptotes. Okay, so our vertical asymptotes, we're going to have one at negative 2 pi, negative pi, 0, so I have one right along the y-axis, positive pi, and positive 2 pi. Okay, so I can do this shading trick for this cotangent function as well. And so the sine, SIGN, of our cotangent function in each quadrant, well, cotangent is just the reciprocal of tangent. And when you do a reciprocal, it doesn't change signs, SIGNs. Like if you have x over y or y over x, it's going to be the same sign, positive or negative. So cotangent is positive in quadrant 1 and quadrant 3, just like the tangent function. And cotangent will be negative in quadrant 2 and in quadrant 4. Okay, so how is that going to affect our picture? So for an angle of 0 to pi over 2, our cotangent function is positive. So from 0 to pi over 2, 0 to pi over 2, our cotangent function will be above the x-axis. From an angle of pi over 2 up to pi, from here, pi over 2 over to pi, the cotangent function is negative. So from pi over 2 over to pi, our graph will be below the x-axis. And the pattern keeps going just like it did for the tangent function. So I'm going to shade in those regions. And similar on the negative side. encourage you to graph the cotangent function on your calculator. Now, there is something weird about cotangent. To graph on the calculator, you can't just press a button that says cotangent, okay, because there isn't one. There's a tangent button, but not a cotangent. But what we know is that we know that cotangent of theta is 1 over tangent of theta. That's one of our reciprocal identities that we talked about in part 1 of the videos. So that means to graph y equals cotangent of x, instead graph y equals 1 divided by tangent of x. And if you do that on your calculator, and I would encourage you to pause and graph that on your calculator and see what happens, but here's the picture that I think you should get. Okay. Your picture should show up in the shaded regions, should cross the x-axis at the dots, and have vertical asymptotes. To make that happen, here is what the shape should look like. Okay. Very similar kind of spaghetti-like structure to the y equals tangent function, but now these pieces are going downhill. They're decreasing along each branch rather than increasing or going uphill along each branch. So now we have a picture of f of x equals cotangent of x. All right. Final piece of information that we want to talk about here is we always want to talk about the properties. Again, this is important in terms of a first date with a function. You always want to ask on a first date, what do you like to do? What's your job? All of those sorts of things. Important features about the cotangent function, properties of f of x equals cotangent of x. Our domain are the allowable inputs, which means every x value except for where the vertical asymptotes are. So our domain is all x values except x equals, okay, I need 0 in there, plus or minus pi, plus or minus 2 pi, plus or minus 3 pi, etc. Our range, the range are the allowable y values, and I get all of the possible y values from really, really, really high. This basement ceiling's kind of short, so you can't get that high in here, but you could if there was a hole in the ceiling. All the way down from positive infinity to negative infinity. So our range is negative infinity up to positive infinity. Okay. The period for this function, well, it takes to get through one of these pieces of spaghetti, through one branch of this cotangent function, takes a distance of pi. So the period for the cotangent function is pi, just like the tangent function. And finally, our vertical asymptotes are, well, it's all the x values that are not part of the domain. So our vertical asymptotes are x equals 0, x equals plus or minus pi, x equals plus or minus 2 pi, etc. Okay, so take a look at this cotangent function one last time. Okay. When we talked about the tangent function, our graph started low and kind of went up, and so into the sort of Saturday Night Fever version. And that was in a positive trajectory. From left to right, the tangent function went from low up to high. On the other hand, the cotangent function, that guy starts high and goes down low. Okay, so on the cotangent function, each branch of the graph, this repeating branch, decreases from left to right. Okay. So y equals cotangent of x decreases along each branch from left to right. Okay. The tangent function increases, the cotangent function decreases. All right, that's all for now. Thanks for listening.